Reach down, touch the floor. Every atom under your hand used to be smoke. A cloud so thin that a cube of it, a kilometer wide, weighs about as much as 1 grain of sand, 10 degrees above absolute zero. Blacker than anything you have ever stood inside. That is your only ingredient. That is the entire shopping list. And somewhere in the middle of this recipe, there is one step where the models say, your planet should not exist. Not might struggle. Should not exist. Hold that thought, because first, there's a problem. The cloud won't collapse. It's balanced. Gravity pulling inward, gas pressure shoving back. It can sit like that for millions of years, doing nothing. So something has to hit it. And we know something did. Inside the oldest meteorites, there is shrapnel from a dead star. Isotopes that decay away in a few million years. So they had to be made right before we were. A star nearby detonated. The shockwave hit our cloud like a hand slamming a table. And the balance broke. Now everything falls inward. But the cloud was already turning. Barely. And as it shrinks, it spins faster. Same reason a skater pulls their arms in. It flattens. It becomes a disc. 99% of the material dumps into the center and ignites. You now have a newborn star and a spinning plate of debris. And running through that plate is an invisible line. Cross it, and the recipe changes completely. That line is the frost line. Inside it, close to the star, it's too hot for ice. Water stays a gas. It refuses to settle. So everything you can build with is rock and metal. And here's the ugly part. Rock and metal are barely 0.5% of what's out there. The rest is hydrogen and helium. Useless to you. You are building a world out of the crumbs at the bottom of the bag. Outside the frost line, ice condenses, and there's suddenly 10 times more solid material lying around. That's why the outer planets are monsters, and the inner ones are pebbles. Now, the actual building. It starts absurdly gently. Grains of dust the size of smoke particles drift into each other and stick. Static cling, basically. Millimeters, centimeters. Pebbles, it's working. And then you hit the wall. The wall is 1 meter. Below a meter, things stick. At about a meter across, collisions stop being gentle. Boulders hitting boulders don't merge. They shatter or they bounce off each other. And it gets worse. The gas in that disk orbits slightly slower than a solid rock does. So your boulder is flying into a permanent headwind. It slows. It loses altitude. It spirals. A 1 meter rock where Earth is now would fall into the sun in about a century. A century. Out of 4.5 billion years. So every boulder should either be smashed to dust or swallowed by the star long before it becomes anything. Nothing should ever get bigger than a meter. And yet you are standing on the proof that something did. Here's the escape. The pebbles never had to become boulders. Because when enough pebbles drift together, they start dragging the gas along with them. Less headwind for the pebbles inside the swarm, which means they slow down less. Which means more pebbles catch up and join. It runs away. The swarm thickens into a dense, choking cloud of gravel. And then the whole thing collapses under its own gravity in a matter of orbits. Not a meter, straight to 100 kilometers. It skips the wall entirely. Now you have planetesimals, millions of them. And now gravity finally works for you. The biggest ones bend the paths of everything nearby, pulling in far more than they'd catch by chance. The big get bigger, faster. Within a million years, you have moon-sized bodies. But a clock started the moment the star switched on. And something enormous has begun moving toward you from the outside. The clock is the gas. The star's radiation is blasting the disk apart, and in 3 to 10 million years, all that hydrogen is simply gone, blown out into space. If you want to be a gas giant, you build now or never. Jupiter built now. And then, according to the leading reconstruction, Jupiter did something horrifying. It fell inward, dragged by the very gas that fed it. The largest object in the solar system besides the sun plowed toward the inner planets, scattering, wrecking, feeding. It came in as far as Mars's neighborhood before Saturn caught it in a gravitational tug-of-war and hauled it back out. That single pass may be why Mars is a runt. Jupiter ate its supply. We know this is real because we see the systems where nobody hauled the giant back. Thousands of them. Gas giants roasting in orbits tighter than Mercury's, circling their stars in days. Whatever rocky worlds were in there first were pushed into the star or flung into the dark. You survived it, but your planet is not finished. The most violent chapter hasn't started yet. With the gas gone, the leftover embryos have nothing to damp their orbits. They cross, they collide. For the next 100 million years, your world is hit by other worlds. One of them, roughly the size of Mars, hits at an angle. The impact vaporizes a huge fraction of both bodies. Your planet turns into a glowing ball of molten rock with a ring of debris around it. That ring becomes the moon. That's not a metaphor. That is the current best explanation for the thing in your sky. And now, finally, you have a planet, a dead one. A uniform ball of hot rubble. It needs a heart. The heat does it. Between the impacts and the radioactive decay inside, the whole thing melts. And in a melted planet, iron is heavier than rock. So the iron sinks, every drop of it falling toward the center, and the falling itself releases more heat, which melts more, which drops more. It's a catastrophe. We literally call it the iron catastrophe. In perhaps 30 million years, the metal has drained out of the rock and pooled into a core. That core is churning. Liquid metal, spinning, conducting. And spinning conducting liquid generates a magnetic field. You've just built a shield. You are going to need it in about 10 minutes. Because young stars are savage. Your sun is throwing off a wind hundreds of times fiercer than today's, with ultraviolet that strips molecules straight off the top of an atmosphere. Mars had a core dynamo once. We can still read the frozen magnetism in its oldest crust. Then it cooled. The dynamo died. The shield dropped. And the solar wind spent 4 billion years peeling Mars's air away into space. We've watched it happening. Your planet keeps its shield, so it can finally get an atmosphere. Volcanoes belching out steam and carbon dioxide and nitrogen from the melt. But not the water, not most of it. Remember the frost line? You built inside it, where water couldn't settle. Your world should be bone dry, so we checked the fingerprint, the exact ratio of heavy hydrogen in Earth's oceans. It doesn't match the comets. It matches a specific family of asteroids from out past the frost line. Rubble thrown inward during all that chaos. Every ocean on this planet was delivered. And there is one ingredient older than all of it, the atoms. The oxygen in your water was fused inside dying stars. The carbon in you was made in the same forges. The iron in that core, the shield that saved the air, came from stars that exploded before the sun existed. You cannot make a planet from scratch. There is no scratch. There is only wreckage, reused. And here's the last thing. Add up everything you just built. All of it. Every ocean, mountain, every atom of every person who has ever lived. It is 3 millionths of the mass of the sun. The star took 99.86%. Jupiter took most of what was left. Earth is what was still falling when the lights came on and the gas blew away. A planet is not what the universe builds. A planet is what the universe fails to swallow. You're standing on the part that got away.